So today we're going to be talking more constructions, and for today our construction on page 25 will be inscribed and circumscribed shapes. Okay, so if you could please take a minute and turn to page 25. Okay, so let's turn to page 25. Date our notes. Perhaps this week we'll take them out to the movies or see a show. Our objective is to inscribe a square, regular, triangle, regular, hexagon. Okay. So the first thing we need to talk about is, what does regular mean? So a regular shape is a shape where all sides and angles are equal. Vocabulary word. I lost my blue marker, so I'm just going to highlight it in blue. Okay, so that's a vocab word. So, regular shape is a shape with all sides and angles equal. So, a square would be a regular quadrilateral. A equilateral triangle would be a regular triangle. The hexagons we made today in class are all regular. Okay. Inscribed means that a shape is drawn within another shape so that all vertices, that's the corners, of the inside shape touch the sides of the outside shape. So what does this mean? If I were to draw a square, and if I were to inscribe a triangle, that might look like this. Okay. If I were to draw a triangle inscribed in a circle, that might look like this. So the triangle is inscribed in the square and circle. Circumscribed is like the opposite of that. So circum means around, like circumference, or circumnavigate, that means go around the world. Okay, so circumscribed, inscribed means written, so in means inside, and so in written, around written. Okay, means that drawn around another shape so that all sides of the outside shape touch the corners of the inside shape. Okay, so if I were to circumscribe a triangle around a circle, so if I were to draw a circle and circumscribe a triangle around it, it might look like this. Okay. So the triangle is circumscribed around the circle. Okay, and the circle doesn't really have any corners, so as long as the edges of the triangle touch the circumference of the circle, we're good to go. Okay, so what we're going to practice today is we're going to practice inscribing shapes into a circle. So the first shape we're going to inscribe is an equilateral triangle. So the hard part about this is this equilateral part. The fact that all the sides have to be equal. So we're going to start by making a circle on our paper. So make sure we pick a point to be the center first. And use C for center. It's also the initial of my first name, so that's kind of cool. There we go. Okay. I'm going to take my marker and I'm just going to outline that. So you can see it on the video. You don't need to outline it, but I just want to make sure it's clear on the video. And now I need to make an equilateral triangle. Now, today in class we discussed how one might make a 12-sided figure by bisecting the sides of a hexagon and adding an additional vertice on the circle. We're going to kind of work backwards. We're going to start with a hexagon. So I'm going to start by making an equilateral triangle. Okay. And I'm using my handy dandy straight edge. I'm going to make my triangle. Yeah, there we go. So here's my triangle and the first part of a hexagon. And rather than bisecting these sides, I'm going to do the opposite. I'm going to go backwards and I'm going to reduce them by 1. I'm going to take and skip this middle vertice over here and just go straight from one vertice to the other. And this will be one length of my equilateral triangle. Okay? And then I'll do that again. So I'll take, and from here, I'll make 2 of the sides of the hexagon. And then I'll take and reduce them to 1 by skipping the vertice. So there's the next side of my equilateral triangle. And since I already have 2 sides to the equilateral triangle, I can come up with the third pretty easily by connecting the 2 over here. And there is my equilateral triangle. Now what we are essentially doing is we are creating this triangle by figuring out what the central angle should be. So what is a central angle? Well, the central angle of any shape is if you were to take the center of the shape and draw from the center to each vertice, it would be this angle right here. And figuring this angle out, we can do one of 2 ways. So this is another one. There are 3 central angles. And since I have a regular shape, all 3 central angles are going to be equal. Now, I know there's 360 degrees in a circle, so if all 3 of these angles are equal, there's 120 degrees in each angle. Or I could figure it out by knowing that these are 2 equilateral triangles, so each of these little angles in here of the equilateral triangles are each 60, so that's 120. So essentially I made 3 120 degree angles and connected their endpoints. So we'll get to the notes on this. First, let's do the steps for how to do this. 1, construct 2 equilateral triangles using the radius of the circle. Cool. Then we will connect call this A and B. Vertices, remember vertices is just a fancy word for corner, A and B. Okay, and then what we can do to kind of simplify this work is we can measure from A to B and mark that off. Measure from A to B and mark that off on this side of the circle. Okay, so 3. Measure from A to B, mark off the third vertice on the circle using this length. So now we're going to construct a square. But before we get there, I want to talk briefly about central angles. Where did I put my green marker? I had a green marker. I don't know where it went. That's frustrating. So let's go over here. Oh, there's my green marker. Okay, and our blue marker. And let's talk about what a central angle is first. Okay, a central angle is created by drawing an angle from one vertice to the center to the next vertice. So if I were to draw, let's say a square, here's the center of that shape, my central angle would be right here. So one vertice to the center to the next vertice. Okay? In a regular polygon, the measure of the central angle is 360 degrees divided by the number of sides. So for an example, in an equilateral triangle, it would be 360 divided by 3 is 120 degrees. In a square, it would be 360 divided by 4 is 90 degrees. In a regular pentagon, it'd be 360 divided by 5 is 72 degrees? Yes, 72 degrees. Okay, and we can inscribe regular shapes into circles by knowing this. So if I were to inscribe a square into a circle, I'd want to make a 90-degree angle inside the circle. So how to inscribe a square in a circle. Okay. So first things first, I want to make a circle. Give myself a center first to go from. Call it center N. You see that okay? Center N. Okay. And again, you don't have to put this in marker. I'm just going to put it in marker so that you guys can see my construction through the video a little bit better. I know sometimes it's hard to see pencil on the videos. Okay. So to inscribe a square, I need to make a central angle of 90 degrees. So I'm going to start by making a straight line through the circle. It's called a diameter, right? Goes through the center, straight line going from edge to edge, called diameter. Now, I know how to make a 90-degree angle. To make a 90-degree angle, I simply need to make a perpendicular bisector. So I'm going to make a perpendicular bisector of this line segment. Ooh. Hold on, let me make sure that that's right. That's not quite right. My compass moved. So I'm going to make sure that this is right, because I don't want it to be wrong. So if your compass moves, you got to kind of restart this whole process. I'm going to try this again. My compass is getting pretty loose. No, it's not coming together. Do I have another compass somewhere? I'm so frustrated. Here. I'll get another compass going. One that won't move on me. Okay. So now I've got a compass that won't move. Yay me. Okay, that's good. And that's good. Alright, so now I draw my perpendicular bisector. And where this perpendicular bisector meets, those are going to be the four corners of my square. there's my square. Let me highlight it for you. Pretty nifty. So, how did we do this? Where's my pen? There's my pen. Okay, step 1. Draw a diameter. Step 2. Draw the perpendicular bisector of the diameter, which coincidentally is also a diameter. Okay. Connect the 4 points where the diameters intersect the circle. That's all, folks. Sorry it was so long.